Assalamualaikum warahmatullahi wabarakatuh. Uh, Today we want to present our paper with the title of Study of Economic Viability of Floating Photovoltaic Electrical Power in Indonesia. Before we present our paper, let me introduce my team. The first is Pak Adi Apriyanto Wijaya. He is the General Manager of Business Development Unit PT PJB, and also Pak Trenindya Gunawan. He is a manager of business development unit, and Pak Bagus Dwi Hidayanto, and myself, Adrian Akbar Untoro, and Pak Fransiscus Perkasa. We are a commercial analyst in business development unit of PTPGB. Okay, today we want to explain about the implementation of renewable energy in Indonesia, especially solar floating development in Indonesia. Before we go to the solar floating, we want to explain about the government regulation related to the energy mix target. Basically, the government has already issued a regulation plan to achieve the energy mix target in 2025, where the renewable energy allocation would be 23%. So, as we know, in the recent condition or in the recent implementation of renewable energy in Indonesia is very low. As you can see, Indonesia has many resources of renewable energy from geothermal, hydro, wind, bio, and solar energy with a huge potential. For example, in geothermal, we have 20 gigawatt, but the realization or the implementation is only about 1.9 gigawatt, 2 gigawatt. And the hydro with the potential is 90 gigawatt. The realization or the implementation is 5.042 gigawatt, which is the highest realization of renewable energy in Indonesia. And then there is wind also with the 0.076 gigawatt of realization. And by energy, with the potential is 33 gigawatt and the realization is 1.8 gigawatt. And the highest potential, solar energy, with 200 gigawatt, the realization is only 0.15 gigawatt. So there is huge potential to achieve the energy mix target that the government has already decided, 23% in 2025. So as we know that the solar energy is the highest potential, so we have to develop or we have to implement the solar energy. The first reason is the highest potential, and the second reason is the price of the modules of the solars already decreasing until now, because the vendor or the developer or the solar manufacturer invent or to create more effective solar modules, so the price will be competitive. And from the data that is achieved by us, that the implementing the utility scales of solar energy can also lower the tariff more competitive compared to the development of small scales of solar floating, 1 megawatt, for example, 10 megawatt. It would be more competitive if we develop utility scale of solar floating, for example, 100 megawatt, 150, and so on. The price would be more competitive. And also, the land acquisition is still becoming the problem for developer when they want to implement the project. So the alternative solution is implementing the solar PV in water surfaces. means that the developer don't have to do land acquisition. They just can use the existing water surfaces to develop the project. And when we implement the solar floating, where we put the solar module in the water surface, solar floating means that we put the module in the water surface. Beside we don't have to do land acquisition, the effective of the and also the performance of the solar floating power plant is more efficient if we compare to the land-based solar power plant, because the temperature in the water surface is lower than the land. So we could increase the efficiency of the power plant. So it means that the solar floating is more efficient than in land-based solar power plant in terms of the performance of the power plant. And as we know that we have a lot of dam potency in Indonesia, 65 operating and under construction dam, and also 220 potency of them. So the potency is huge when we want to implement the solar floating. And then in the right side is the data of the irradiation in each location. That each location has a different, as you can see that each location has a different solar irradiation, which lead to different energy yield. As we know that if we can produce more energy yield, we can could produce the lower tariff. So in East Java, the irradiation is almost 5.26 until 5.37, and the East Nusa Tenggara, which has highest irradiation, 5.76 until 5.92. So this is the irradiation data in each location, in each province in Indonesia. And then we talk about incentive or fiscal perspective that government has already granted to the developers. There is two kind of incentive. The first is tax holiday, and the second one is tax exemptions. The first is tax holiday. The developer could get deduction of corporate income tax, which categorized as based on the investment value. For example, with investment value at least 500 billion rupiahs, the deduction of corporate income taxes that the developer could get is 100%. But if the investment value is 100 billion rupiah at most, and at most less than 500, the total corporate income taxes that could be deducted, it's only 50%. And also the period itself, there is categorized based on the investment plan, 5 years, 7 years, 10 years, until 20 years. And the second one is tax exemption, is the facility that could be granted, that could be achieved by the developer, but it's basically only for the foreign equipment that is imported from the outside of Indonesia. But it is limited equipment. It's just the equipment that cannot be produced in Indonesia. So if the equipment is not cannot be produced, so the government will be, so the developer will import, and also the developer could get the tax exemption. Basically, the exemption is import duty 5 to 15%, and the import VAT 10%, and the income tax articles 2.5%. This is the incentive tax holiday and tax exemption that could be granted by the government for the developers, especially in this case is renewable energy developers. So this is the method. This paper focused on commercial perspective and technical, which affect the commercial aspect. There is three things that we do. The first is site potency identification to assess the solar energy potency, and then we can get the solar PV energy yield, which lead to the tariff increasing or lowering, which affect the tariff. In the site potency identification, in this paper, we focus on a dam or a location which has a water surface more than 100 hectare to develop the utility scale of solar floating PV. So the tariff would be more competitive. And also the target of renewable energy mix would be achieved because we develop utility scales, means that we develop large scale of power plant. And the second one is incentive. We also evaluate or assess the effect of the incentive to the tariff. And the third one is we also evaluate or assess the financial parameters, the EPC price, the recent EPC price, the interest rate, and their related to the recent condition to the tariff calculation. And finally, we compare the tariff that has been produced based on the three aspects to be compared with BPP electricity generation cost, national electricity generation cost, local electricity generation cost, because the government also issued a regulation related to the price of renewable energy, which have to be below the local electricity generation cost or national electricity generation cost. Okay, the first one we discuss or we explain about the assessment of financial parameter. This is the assumption based on the recent project in Indonesia. The PPA term is 25 years. The interest rate is LIBOR plus 2.6%. The tenor is 16 years, and the debt to equity ratio is 80 to 20, and the discount rate is 10%. As you look at in the right one, the EPC simulation, there is three project costs: EPC cost price, dollar per watt peak. There is 0.7, 0.4, and 0.6. 0.7 is from the data in India, the development of solar floating PV in India. The price achieved 0.4 because in India, they can develop the floating system, which is more effective, and then the price would be competitive. So this is also become concern to develop renewable energy, especially in Indonesia, if they want to reduce the tariff of solar floating PV. So the government should develop the ecosystem to develop floating system to support the the PV in solar floating PV development. So the India could get the competitive tariff, lower tariff, if we compare with the others. In the recent world, the renewable energy, especially solar floating PV, the price of the EPC is almost 0.7 and 0.8 is based on 2019, 18 to 19. The price still 0.7. But actually, in Indonesia, based on the last project that we in Indonesia, the tariff could achieve $0.6 per watt peak for the EPC price. So it means that the tariff is more competitive today. The tariff, the resulted tariff, still for in if the price is 0.6 is almost 6.2 cent USD per kilowatt hours, and then for the India it could in 0.4 it could achieve in 5 cents. So basically, the EPC simulation is based on debt to equity ratio is 80 to 20. So in the below their simulation, if we use or if you get the debt portion is only 70%, it could increase the tariff to 6.6 cents USD per kilowatt hour. So it means that now in recent condition, the bank already experience in financing the renewable energy project, so that's mean that they want to contribute more. So I think the portion of 80% from the project cost, I think the bank will do that, considering the maturity of the technology of solar PV and also the experience of bank itself. So it means that the bank consider to finance the project with the debt to equity ratio 80 to 20. And then we talk about the incentive that the government granted to the developers, is tax holiday and tax exemption. As you can see that both of them can reduce the tariff almost 1.8 to until 2 cents USD per kWh. But if we implement the both incentive, it could reduce the tariff from 6.2 to 5.8 cent USD per kilowatt hour. Okay, so ladies and gentlemen, as we have implemented the financial parameter, EPC price, interest rate, debt to equity ratio, and also the incentive, we projected the tariff in each location, considering the solar irradiation, considering the energy yield projection. Means that in Jawa Barat we could produce tariff 5.8 cent USD per kilowatt hours, and in Nusa Tenggara, which is the highest irradiation, which is the highest yearly total electric production, we can get the tariff 4.9 cent USD per kilowatt hour. So in Jawa Barat, if you compare with the local local and electricity generation cost, which is 6.91, it is the resulting tariff is lower than the local electricity generation cost in Jawa Barat 2018. In Nusa Tenggara Barat is more low if you compare with the local electricity generation cost, which is 17 cent USD per kilowatt hours. So basically, the result tariff is lower than the locals electricity generation cost. Even if we compare with the nationals electricity generation cost, the both tariff is still below 7.86, which is the BBP nationals, or the national electricity generation cost. So the conclusion is, the first, based on the simulation tariff of floating solar PV, it is noticed that the tariff could reach 4.9 and 5.8 cent USD per kilowatt hour. Consider the recent EPC price, debt to equity ratio incentive that could be granted by the government, where the incentive from the government could reduce the itself could reduce the tariff 0.4 cent USD per kilowatt hours. The second was, it is noticed that the resulting tariff is below the BBP, if national electricity generation cost, national BBP, and even in a local electricity generation cost or local BBP. Then, by implementing the utility scale of floating solar PV, it will achieve the energy mix target, and also it reduce the investment cost of floating solar PV. And the third one, it is recommended to do further studies related to the demand in each area, the electricity system in each area, to make prioritization of floating solar PV development, not only in economic perspective, but also in technical perspective, as we have explained before, related to the demand and the electricity system. Okay, thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.